Today we're doing day 2 of elimination and using that method to solve a system. So we started this last time, and last time we did like the easier examples. Today they're going to be the more challenging examples. So if you remember what we talked about with elimination last time, what you do, we said that you add the equations together to get rid of one of the variables. So that was kind of like the brief explanation of what you do when you use this method to solve a system. I'm going to give you guys some concrete steps to use. We did these steps last time, but this time it's going to be especially important since these are the more challenging examples. So remember that you have to get both of the equations in standard form because everything needs to be lined up before you add them together. And before you add them together, step 2, this is the crucial one, so I'm going to put a star next to it. You absolutely have to have this in your setup before you can start the problem. So remember from last time that you must have the same coefficients in front of the variable that you're eliminating. And a coefficient, it sounds really fancy, but if I'm looking at a term that's maybe just like 3y, the coefficient is just the number in front of the y. So in this case, it'd be the 3. Okay, so I have to have the same number, we'll say, in front of the x's or the y's, and they have to have opposite signs. So one of them needs to be positive, one of them needs to be negative. Once you have that, then you're ready to add the equations together. Once you've added them together, then it should be really easy to solve for one of the variables. And remember that when you find one variable, you have to go back and you have to plug that in to solve for the second variable. So you kind of feel like you're finding two different answers. So we're just going to jump right into some practice of these. I already mentioned that these are the more challenging examples because they don't have the same coefficient in front of the x's or the y's. Last time, that was already there. So we're going to have to make that happen on these examples. Before you do that, you have to find, just like with substitution, yeah, you can make it happen anywhere, but you're going to save yourself a lot of trouble if you find the most convenient place to make it happen. Once you figure that out, then you can go ahead and multiply one, or sometimes we have to multiply both of the equations to get the coefficients the same. So let's just look at example A, and again I'm going to take a step back and kind of look at this thing and try to find the most convenient place to get my setup how I want it. So I notice that in front of the x's I have two different coefficients, same thing with the y's. So I know I'm going to have to do some multiplication before I can start. Now this one's not too bad either way. You could make the x's the same or the y's, but if you look at the y's, that would jump out at me because I have 6 and I have -2. So I know that if I just multiply the 2 by a 3, then I'm going to have it being a 6. And then I would have exactly what I want. I'd have +6 and -6. If you looked at the x's, there's nothing that you can multiply the 3 by to get a 5, at least a whole number. So if I can avoid making the x's the same, I'm going to. The y's is a much simpler place. So what I'm going to do is I'm going to put the second equation, because that's the one I'm changing, put the whole thing in parentheses. And last time we only ever had to multiply by -1, but this time I'm completely changing the number, not just the sign. So I'm going to multiply by 3. So that way this becomes a -6. Your signs are what you want. One already is positive and one already is negative. So don't mess with any signs, just multiply by a +3. And a place that people make a common mistake is they forget to multiply all 3 terms by 3. But all of those have to be multiplied. So be really careful there. All right, what I'm going to do is I'm going to go ahead and just copy the first equation down below. And then I'm going to distribute 3 to the second equation and change every single number in that problem. So I would have -15x minus 6y, and then 14 times 3, that would equal -42. All right, I changed the original problem, so I'm just going to cross off kind of what I started with. Now here's my system that I want to look at. I've got 6 and negative 6, so now I'm ready to do step 3 and add the equations together. Okay, be really careful with your signs here. Don't make a small mistake because it'll throw everything off. 3 plus negative 15 is negative 12x. 6 plus negative 6 is 0. So the y's eliminate. Don't even write them. Bring down your equal sign. Negative 6 plus negative 42 is negative 48. Now I have a really easy one-step equation that I can solve to figure out x. It should be what, positive 4 when I divide by negative 12. Okay, so I have kind of half of the answer. Remember, your answer is an ordered pair. I have the x value. Step 4, don't forget it. You have to bring this back up and plug it in somewhere to find the y value. Now realize you can plug it into like your new equations, ones after you multiplied, or you can plug it into the originals. It does not matter where you plug it in. You should get the same y value no matter what. So I'm just going to plug it into this one, which was the original first one, only because the numbers are a little bit smaller and I have less negative signs. So I'm probably less likely to make a mistake if I do that. So I'm just going to copy that down here. Let's see, it was 3x plus 6y equals negative 6. I know that x is 4, so I'm going to stick that in. And then I just have to solve that for y. So that'd be 12. Now it's just a two-step equation. So it'd be 6y equals negative 18, and then when I divide by 6, y would equal negative 3. You can write your answer as an ordered pair, or you could just leave it x equals 4, y equals negative 3. It means the same thing. All right, let's do another one. So example B, again, right off the bat I would notice, okay, I've got 3 and negative 10 as my coefficients for x, and I've got 2 and 5 for my y's. So I'm going to have to do a lot of multiplication here to get my coefficients to match up. I would look at the x's and I'd think, oh, there's nothing I can multiply 3 by to get 10, and there's nothing I can multiply 2 by to get 5. So if this is the case, I'm going to have to multiply both equations to get my coefficients to be the same. So here's what would go through my head. I would look at the x's and it would jump out at me that I already have the signs what I want. Like I have a positive and I have a negative. So for me, I would make the x's the same. You could totally make the y's the same, but since they're both positive, you would have to throw a negative in there. But for the sake of me not having to do that, I'm going to go for the x's. So guys, the easiest thing, just do 3 times 10. Aim to make both of the x terms 30. So you're going to have to put both equations in parentheses. I'm looking to make these 30s. So the top equation, I need to multiply it by 10 to get me 30 x's. And I need to multiply the bottom equation by 3. So that'll be negative 30. So just be really careful here that you don't miss anything with your distributing. So when I multiply the top equation by 10, I get 30x plus 20y equals negative 90. And then on the bottom equation, I'm going to distribute a 3 through to that. So that would give me negative 30x plus 15y equals negative 15. Now I'm ready to add them. So 30 plus negative 30 is 0. Those eliminate. 20 plus 15 would be 35y. And then negative 90 plus negative 15 would be negative 105. Okay, that's pretty easy to solve. When I divide by 35, I get negative 3. And then as always, you bring it back up and you plug it in. You have 4 options where you can plug it into here. You can go to the original 2 or the new equations. I'm going to choose to go for one of the originals because the numbers are smaller. So I'm actually just going to go for the very first equation. And I know that y is negative 3, so I'm going to plug that in right there next to the 2. And then I'm going to solve this for x. So I'm going to say minus 6. And then I'm going to add 6 over and divide by positive 3, and I get x is negative 1. Okay, so it's kind of a lot of work. There's a lot of places to make errors. which is not ideal, but if you just kind of slow down and take your time, it's actually not too difficult of a method. I want you guys to try example C, and I'm going to go ahead and do D for you here. Now, the difference between the last one, example B, and example D here is that you will have to change the signs. And you guys are going to have to do that on example C as well when you try that on your own. So pay close attention to this one. I've got 3 and 5 as my coefficients for x and 5 and 7 for y here. And they're all positives. So I need one of them to be a negative, so I'm going to have to throw negatives in. Now, for me, since kind of one's not set up sign-wise how I want, the way I would decide whether I want to do x's or y's is I would go for like smaller numbers. So 3 times 5 is 15, 5 times 7 is 35. So for me, I'm going to think, 15 is a little bit better to work with, so let me just get the x's the same. And you're going to have to multiply both equations here. Again, I'm aiming to make both of them 15, so I'm going to multiply the first equation by 5 and the second by 3. I need one of these to be negative 15, so I need to throw a negative on just one of these things that I'm distributing. Don't do it on both, because then they're both negative. So I'm just going to pick to make the 3 negative. Okay, then be real careful when you're distributing that you don't miss something. So when I multiply by 5 on the top equation, I get 15x plus 25y equals 50. Negative 3 being distributed on the bottom would give me negative 15x minus 21y equals negative 30. Okay, not paying attention to those. Now I'm going to add these two together. 15 plus negative 15, those eliminate, that's 0. 25 plus negative 21 is going to give me 4y. 50 plus negative 30 is 20. So when I divide by 4, y is going to be 5. Okay, so that was not too terrible. I know I need to plug it back in to get the x value. And again, I'm going to go for one of the original problems because the numbers are smaller. So let me just maybe go for the top one. So that's 3x plus 5. I know that y is 5, so I'm going to plug that in there and then solve this. So two-step equation here would be negative 15, and then when I divide by 3, x is going to be negative 5. Okay, we've got one more because I want you to remember and keep in mind that the special cases do show up here. So this one's a special case. Let's see why. I would step back and I would see, all right, do I want to get x's the same or y's the same? I'd go for x's because they're smaller numbers. And look, if you just take this first equation and you multiply it by negative 4, then you'd have positive 4 and negative 4. So if you distribute it all the way through, it'd be negative 4x minus 20y equals negative 40. So I'm going to cross off that original first one, and I'm going to add these two together. 4 plus negative 4, 0 x's. 20 plus negative 20, that's 0 y's. So when I add, everything on the left-hand side canceled out, so there's nothing there. It's just 0. Ooh, and look at the right-hand side. 40 plus negative 40, that's 0. So just keep in mind that when your x's and your y's eliminate here on elimination, it's a special case. You look at what's left. There's no variables, so this is just 0 equals 0. That's a true statement. And remember, when what's left is true, that means it's infinite solutions. And if we were graphing this, it would be the exact same line. Remember, they cross at all points, so they have infinite answers. Okay, so be on the lookout for those. Now, I will tell you that next lesson, we're just going to be doing word problems. So for the sake of time here, I'm just going to set this one up. I'm going to write the system to represent this situation, but we're not going to solve it, because next time we're really going to focus on application problems. So let's just read it and set it up, and then we'll end there. Suppose the band sells cans of regular popcorn for $5 and cans of caramel corn for $8 per can. The band sells a total of 240 cans, and they made 1614. I want to find the number of cans of regular popcorn and the number of cans of caramel corn that the band sold. So, and again, we're going to talk about this more next time, but we're talking about systems. So if I give you a word problem, you better write two equations, and there better be two variables. So let's define the two variables first, and the last sentence gives away what they are. I want to figure out number of cans of regular popcorn. So we'll say cans, regular popcorn, and the number of cans of caramel corn. So there's always two variables in these word problems here. Regular popcorn, caramel corn. Now I need to put all of this information together into two equations. This one's a little tricky, but we're going to see this a lot. With more practice, you'll get better at kind of picking out the two equations. But if you notice all the numbers here, some of them are dollar amounts, but then this number is not. So the way you can kind of organize the information here, one equation has to do with the money that the band made. So all those dollar amounts that I circled need to go together with R and C to make up that first equation. So here's what it's going to look like. They made $5 per can of the regular popcorn, so 5R, and they made $8 per can of the caramel corn, plus 8C, equals how much money they made. So that would be the first equation. I dealt with all the money amounts. There's only one number left, and it's 240, and that's how many cans of popcorn they sold between the two types. So this equation is just about the number of cans, and it's really basic. I know between these two types of popcorn, there were 240, so it's just regular plus caramel, 240 cans sold. All right, and we'll learn tomorrow, but when you write an equation or a system of equations for an application problem, you can use any method you want to solve. So I would say this one, it's probably equal amount of work doing substitution and elimination. So you'll get to choose that next time.